Nearly. I'm ready. Go. So, hi. I'm because yesterday there was someone who wanted to know more about like different languages, and I am really proficient. I really like Go. So because there was already somebody who like did an introduction to Rust. This is really awesome. So I decided to do a Go intro. So the most important thing, it has a really cute mascot, so that's one thing. They recently decided to change it to some like type logo, but don't care, this is the mascot. Go is a little different from like interpreted languages like Ruby. So it's always compiled to a statically linked binary in this case. So most of the time you can just take this binary and run it on the platform it was compiled for without like having to deal with any libraries or anything. So it's just a statically linked thing. You can put it in a plain container without anything in there and just run it. It's also statically typed, so kind of like most compiled languages, you will have to assign a type to everything, every variable, every field in your structs. But it can infer many types, so if you create a new variable and directly assign a value to it, it will usually infer the variable type. It uses a runtime. That's a big difference to Rust. Rust is not using a runtime and therefore not doing garbage collection, because they're doing a lot more like, they're doing memory differently. But Rust, Go is using garbage collection, kind of like some interpreted languages would do, to get rid of like unused memory after a function call. Also, a big difference to like object-oriented languages is that we don't have any classes, only structs or types with methods bound to them. I will show you examples. And thereby we have some type inheritance, but not in the way that an object-oriented model does it. Some main features I want to highlight is it has a really nice, large standard library with a lot of features. I think it's kind of like Ruby, so it's not like C where you have to put in all these, I don't know, libraries. It has good concurrency features, and it's mostly memory safe if you respect the conventions it gives you. I wanted to show you a simple like Hello World API thingy. You can build with the standard library, so it just looks like this. The HTTP module in Go will provide you with these primitives to just say, okay, on the path / I want to have a handler that prints hello world, and I want to serve this server on port 80. I also want to show you concurrency, because I think for like really fast backend services, this is an important point. This will work like this, so you have a function that runs in parallel to your main handler and can do something in parallel, like streaming some post request in and reading that and already inserting that in the database at the same time. So if you get many records in, you can parallelize that. That's awesome. The memory safety aspect is a little bit, basically it doesn't guarantee it like in Rust, but so most memory safety aspects are kind of like in C, so you have to use like mutexes to guarantee like thread safety. But if you use Go routines and channels, which I just showed you, so you can put like a value into a channel and it comes out on the other side, like in the other Go routine, and it's kind of like a thread. You can then be sure that the memory is safe and you will not get any race conditions. These are some of the types that are available, like types that are in the compiler, and you can always like build your own types on top of these. One thing I want to highlight, 30 seconds left. So what I think is really nice, if you have a struct, and you might know a struct if you have done some C, you can put these tags onto the struct fields, which help you like deserializing, serializing, putting stuff in the database, kind of like if you had active record in Ruby. And they have these primitives in the standard library that help you with that. Thank you.
Thank you.